do we implement those operations with matrices? So this video lecture aims to do that, to show you how to do that, but at the same time, I'm going to try and expose to you the reading, the syntax, the textbooks that you are familiar with, that you may download, that you may read and realize that as much as the reading and the syntax could prove to be demanding and difficult, the implementation of it may not be as difficult. So let's start. 1.1, equality. What do I mean by equality? Well, when are matrices equal? So here we state two matrices. One is P, one is Q, are equal if and only if all the elements of P are the same as all the elements of Q. That is, Qij is equal to Pij for I greater than or equal to 1, less than or equal to M, J greater than or equal to 1, less than or equal to N. This means that the two matrices must have the same order, M by N. Now, on reading this for the first time, it could prove to be very difficult to understand. Yet, when you break it down, it becomes so easy. So let's start. Let's take two matrices, P and Q. So I'm going to call the one P, some matrix, another matrix Q. And these two matrices are equal if all the elements are P. So let's make a matrix for P and give it a particular order. Oh, let's put this in. Let's just say 1, 2, 3, 4, 5, 6. There's a matrix. The first element is 1. That is in the first row, first column. The next element, 2, first row, second column. And so on. Now I can pick any particular element or entry of that matrix. The order of that matrix, how many rows do we have? 1, 2 rows, so it's a 2 by how many columns? 1, 2, 3. So this is a 2 by 3. The order of that matrix P is 2 by 3. Now to continue, when will P be equal to Q? And here the statement says all the elements of P are the same as all the elements of Q. That is when these two matrices will be equal, which means Q must be exactly the same as P. Every single element that you see there must be the same. So it's got to be the same order, and every single element must be equal. Then we can say P is equal to Q. Now you may say, well, that just stands to reason. That is true. but did it stand to reason when you read it for the first time? And that is the point I'm trying to make. That when you read mathematics, look deeper at every single word, at every single term, and all the syntax associated with that. Let's just make a quick exercise or example. Let's take this here. I'm just creating an example very quickly. If the matrix A is equal to a matrix B, where, let's say A, let's just make it a very small 2 by 2 matrix. So I'll have, let's say, -3, 5, A and 10. So that is a 2 rows, 2 columns. And I have a matrix B, where this is B, 7, -9, and alpha. Find A, B, and alpha. Well, very straightforward. If A is equal to B, and I look at A, that's a 2 by 2 matrix. B is also a 2 by 2 matrix, which means every single element in its particular place is equal to every single element B in that particular place. So for instance, the -3 is in the first row, first column. Therefore, that -3 of A must be equal to the first row, first column in B, must be equal to B. So B is equal to -3. In this case, I'm going to change this very subtly and make that a 5x. Similarly, I could say the second column of the first row, 5x, that must be equal to the second column, first row, 7. Therefore, x is equal to 7 divided by 5. Every single entry. A is second row, first column must be equal to second row, first column. A must be equal to -9. And of course, lastly, 10 is equal to alpha. Now, I need you to look at that very carefully. And why could I do that? Because I stated that the matrix A is equal to the matrix B, which means every element in its particular place, its particular row and column, will be equal to its corresponding row and column in the other matrix. Now, you may think, okay, well, that's pretty easy. Obviously it is. But I can generate lots of algebra from this. Instead of putting a -3, instead of putting a B, I could end up with a quadratic equation. Just by way, that is, I could end up with a complex equation as well, where we have real and imaginary values. I could generate simultaneous equations simply by stating that two matrices are equal. Therefore, every element of the first matrix will be equal to every element of the second matrix. Okay, there is your equal matrices, equivalent matrices. Let's go on to the next slide. Addition and subtraction. Again, just to read through the theory. If two matrices have the same order, now I'm going to highlight same order. then the sum or the difference, okay, I'll just put there or, is the matrix. So analyze it carefully. If two matrices have the same order, so you're dealing with two matrices, you want to add or you want to subtract them, then the matrix, in other words, the answer, consists of also adding or subtracting their corresponding elements. In the syntax, if A has elements Aij and B has elements Bij, then A plus or minus B has elements small aij plus or minus small bij. Now, let's just get this right. That A that you see there is the name of the matrix. I could call it any letter, any Greek symbol or capital letters, whatever. The small letters generally refer to the actual entry itself. So in the matrix A, we have a number of elements, and that I and the J means row and column. So that I and the J could be 1, 1, 1, 2, 2, 3, and so on. Likewise with B and Bij. But then what do we do? When we have to add or subtract, we simply add or subtract each corresponding element. So let's look at the examples. But firstly, what must we check? Order. Let's take example 1. What is this order? How many rows do we have? 1. So there's 2 rows. How many columns? 1, 2, 3. That's a 2 by 3. What are we doing? We are adding. Is this also a 2 by 3? Yes, that's a 2 by 3. Can we add it? Yes, I can. Do we know that we add in? Of course. There you go. We add in the symbol plus. How do we add? Simply the same corresponding elements. So let's just take the first row. First column is 1 of the first matrix. Add it to the first row, first column of the second matrix. What's 1 plus 5? That gives me 6. And I do that for every single entry. So the order of the answer must also be a 2 by 3, which means I must have 1, 2 rows. So I must put 2 rows, and I must have 1, 2, 3 columns. So I'll have, I'm just putting dots there for the moment, and that dots that I'm putting will actually help you to establish the correct answers, the order of the answer, and what you need to do. Okay, let's complete the rest. And I'm pretty sure by now you are waiting for me to complete this because you have done it already. So the next one, I'll go to 2, first row, second column. I'm adding a minus 6 to minus 6. That gives you minus 4. Minus 4 plus 0. That gives you minus 4. In the second row, minus 3 and minus 1. Minus 4. Second row, second column, 0 plus 2. That is a 2. And then 5 minus 5 gives me 0. There's your addition of 2 matrices. Example 2, in this case, we are going to subtract. What's the order? 2 by 2. You are subtracting 2 by 2. So yeah, the answer must be a 2 by 2. How many rows do I have? Notice what I'm doing. I'm just putting dots there. So there's 1, there's 2 rows. And how many columns? 1, 2 columns. So I must have dots over there. There's 2 rows, 2 columns. So each of those entries I need to find. How do I find it? I'm going to subtract. So it would be 10 minus 8. That gives me 2. 2 minus 3 minus 1. In the second row, 4 minus minus 4. Watch the sign. You're subtracting 4 plus 4. That gives me 8. Minus 6 minus 5 minus 11. So adding and subtracting matrices, not that complicated. I would hopefully say that you will be quite comfortable adding or subtracting matrices. And please notice that you can extend this just like you extend ordinary numbers. You can add a number 1 plus 5, you're going to get 6. But then you can add many numbers, 1 plus 5 plus 2 plus 10. Likewise here, you can add and subtract many matrices. So I could, for example, have a matrix P, adding it to a matrix Q, then subtracting it R from that matrix. As long as each of these matrices have the same order, I can do that addition and subtraction. So let's check example 3. Let's start adding pi. That's the first entry. Pi, I'm adding it to A. So that's pi plus A. Is that correct? No, of course not. Are you following procedure? No, I am not. What must I check for first? Same order. So let's check the order of the first matrix. How many rows do we have here? 2. How many columns? So that's a 2 by 3. What about the next matrix? What am I adding? I'm adding a 2 rows, 2 columns. But it's not the same. These two are not the same order. So is this addition possible? No, it is not possible. I cannot add those two. Well, just think about it. Pi add into A, 4x add into 5. What's minus 8 going to do? All by itself. So always check the order for addition and subtraction. Let's go on to 1.3, multiplication. And in the first case, very straightforward, scalar multiplication. What do I mean by a scalar? A simple single quantity. And that quantity could be a number, 5. So scalar quantity. I think we're all familiar with scalar quantity. 5 minus 1, 2.3, 5 over 7. I could also bring in complex. I could multiply by, let's say, 2j, and so on. So let's read. The product of a number and a matrix, also known as scalar multiplication, is defined as the matrix, so the answer, where the elements are simply obtained by multiplying each element by that scalar quantity. Now, once again, the purpose of this video lecture is not only to go through the algebra of matrices, but at the same time to expose you to the writing of matrices, the syntax associated with it. So yeah, I've got A. Now notice what I've done here. I've written each element as a small a, and I've indicated every single element, the row and the column. So A11 means the element in the first row, first column. A21, second row, first column. A23, A23, it's a second row, third column. What about A33, third row, third column? Okay, if A is equal to that matrix, then K times A. What does K times A mean? K multiplied by that A. And because K is a scalar, the theory states that I can take K and multiply into the matrix every single element. So it will be K times A11, K times A12, K times A13, and so on, right till the end. Now, this is also useful, for example, in reverse. Let's take, for instance, a matrix that looks something like this. 2/7 minus 3/7, 1/7, 5/7, minus 4/7, and let's just say 1/7 as well. Now that is a 3/2 matrix. Now imagine adding that to another matrix. Then you will be adding all the fractions. What you could do is simply remove a common factor from all of those entries. And the common factor in this case would be a fraction 1/7. So if I remove 1/7 as a common factor, what will I be left with in the matrix? That will be a 2 because I've removed 1/7. Remember, it's the reverse, so I'm actually dividing by 7. That will be minus 3, 1, 5, minus 4, 1. It will be much easier to work with a matrix like that than to work with fractions. It's useful to know that. Example I have here, very straightforward. If A is equal to the matrix 4 minus 5 minus 1, 2, 0, 7, and it just depends on how you want to say it. You could call the rows out first, or you could call the columns out. It doesn't matter. The first column 4 minus 1, 0, second column minus 5, 2, 7. If I'm going to multiply by minus 2, that means this entire matrix multiplied by minus 2 times 4, minus 8, minus 2 times minus 5, plus 10, plus 2, minus 4, minus 2 times 0, minus 2 times 7, minus 14. Scalar multiplication, I hope, once again, seems to be straightforward. Just to pause at this stage, I am going through these video lectures. I may indeed make a mistake somewhere along the line, and if you pick up anything after going through it sometime, simply email me and I will try and correct that. Right, that's scalar multiplication. Yeah, I've given an example where I've combined both addition, subtraction, and scalar multiplication. So we can, and I'm not going to complete all this. This is for you to double check. But let's just quickly have a look. And I would say the first thing to do when you get questions of this nature, just write on the order of each of these, of each of the matrices that are given. That will help you immediately. So matrix A, what's the order? 3 rows, 3 columns. Matrix B, what's the order? 3 rows, 2 columns. Matrix C, 3 rows, 3 columns. So let's look at number 1. A plus B. So we add in A plus B. What's the order of A? 3 by 3. What's the order of B? 3 by 2. Can I do that? Not possible. Order is not the same. What about A plus C? Can you do A plus C? Yes, the order is 3 by 3. You do that. And of course, if the order is a 3 by 3, therefore, the answer must be 3 rows, 3 columns. All you have to do is find that out. Number 3, 2/5 of C. Again, you're simply going to multiply 2/5 into the matrix C. Number 4, 3A plus 2C, and I would say do these separately if the order is correct. So first you will multiply 3 into A. What's your A? 1, 2, 1, 1, 1, 2, 1, 1, 1. You get an answer. You can write that in. Then you multiply 2 times C. 0, 1, 1, 0, 0, 1, 1, 0, 0. You get an answer. And then this one added to that will give you your final answer. Now I'm deliberately leaving that for you to complete because they are very straightforward. What about number 5 now? What does AT mean? Well, AT means, do you recall? The transpose. What does transpose mean? Or the rows become columns, or the columns become rows. That's right. So let's look at A. Here is A. I need to transpose that. And whichever way you do it, you'll still get it correct. So I'm going to do first row, 1, 2, 1. In the transpose, that row becomes the first column. So the first column will be 1, 2, 1. Then I look at the next row. 1, 1, 2. That is the second row. Rows become columns. Second row becomes second column. 1, 1, 2. And in the third row, 1, 1, 1 becomes the third column, 1, 1, 1. There's your transpose of A. And then, of course, you're also going to multiply 2 into C. What is C? 0, 1, 1, 0, 0, 1, 1, 0, 0. Get your answer and then add those to get your final answer. And can you do that? Yes, you can, because the orders of the A transpose and of the 2 times C is the same. So you can get 3 rows, 3 columns. You find that out. Right, now we get on to matrix multiplication. And this is multiplication which you need to follow very, very carefully. You can see simply by the mathematics, simply by the written work, the definition itself, the writing, the syntax, the mathematical symbols and notation can certainly put you off. So let's start. If A is a matrix of order M by P, right, with elements A, I, J, and B is a matrix of order P by N with elements B, I, J, then the product C is equal to A times B is an M by N matrix with components Cij is equal to the sum of Aik, Bkj, where I goes from 1 to M, J goes from 1 to N, and of course K goes from 1 to P. Now I'm sure that is pretty straightforward for you. That's right. It can be very confusing. Fortunately, we don't need to prove any of these. Neither will I ask you to write it down, the definition, but it's there for you to realize this is the correct mathematical notation that should be used. Let's consider this. We got a matrix A, and there's the order M by P. Of course, A has elements Aij, and then there's a matrix B, and that order is P by N, with its elements Bij. Then the product, in other words, when I multiply A times B, I'm going to create a new matrix. I'm going to call it C. And that C has the order M by N. Now, look very carefully. Where does the M come from? There's the M from the first matrix. There's the M from the second matrix. So we've already established that the order of the matrix must be M by N, where M comes from the first matrix. In other words, the first row, the number of rows of the first matrix, and N is the number of columns of the second matrix. And then every entry, Cij, we have to somehow add elements of the first matrix, multiply by elements of the second matrix, and then also add them, because you know that that means the sum of. Okay, let's break it down. Analysis. And this is a checking procedure that you will do, that you should do, and I recommend you do whenever you have to multiply matrices. So matrix multiplication is only possible if the number of columns of the first matrix is equal to the number of rows of the second matrix. That's the first thing that you will look for. You will find the order of the matrices, you write down the order of the matrices, and then you look at the number of columns of the first matrix, and look at the number of rows of the second matrix. And only when they are equal can you do that multiplication. Now I will merge that into number 2. If A is a matrix of order M by P, and B is a matrix P by N, then the product AB has order M by N. So let's do this here, which is from this entire definition. So imagine I have a matrix A, and I notice that that A has the order M by P. And I want to multiply that by another matrix B, and the order of B is P by N. So A is a M by P, B is a P by N. Firstly, you check, can I do this multiplication? So check. And where does I check by looking at the number of columns of the first matrix? Well, that P represents the number of columns. The M is the rows, it's rows by columns. P is the number of columns of A, and the number of rows of the second, and P over here is the number of rows of B. So when these are the same, then I can say yes, the P is the same. Then yes, I can do this multiplication. So if it's yes, then what is the order of the answer? The order of the answer comes from what's remaining, M by N. There you go, M by N. So the order of the answer will be M by N. In other words, I will have M rows and N columns. That's analysis of the definition. Now, let's put that into practice. But before we do that, that's fine. I can look at the order. And maybe I should do this before I look at number 3. Example 1. A is equal to 476231. B is equal to 859. So let's check the order. The order of A, 2 rows, 3 columns. What is the order of B? Look at that carefully. How many rows? 1, 2, 3 rows. How many columns? Just 1 column. So that's a 3 by 1. Now I do my check. Is the number of columns equal to the number of rows? Yes. So check, can I do this? Yes, I can multiply. Then what is the order of the answer? What remains? 2 by 1. So the order of the answer will be 2 by 1. So what I'm going to do is I'm going to write my answer right here. Then A times. So if A is that, B is that, then A times B will be equal to a 2 by 1, which means I must have 2 rows going that way and only 1 column. And there you go. That's how many elements I must have in the answer, because this is 2 rows, 1 column. Yes, that only gives me the order. Now, how do I get both of those entries? That's when I have to look at number 3. Elements in the product matrix is the sum. Do you remember the summation sign? Of the products formed by multiplying each element of the particular row of the first matrix by the corresponding element of the particular column of the second matrix. Now, once again, that does seem to be a bit confusing. So it will be best if I explain it by way of this first example. So to find out the first element there, what I do is I look at, so I'm going to just show you that, how to obtain that first element. That first element comes from 1, the first row, 1. In other words, it's an A11, which is first row, first column. So I'm going to write out first row of what? The first row of A and the first column of B, always in that order, because you've got A times B. The rows will always come from the first matrix that you see, and the column will come from the second matrix that you're multiplying. So the rows will come from A, the columns will come from B. So to get this particular entry, the first one, first row, first column, I look at the first row of A. So I'm going to write down the first row. The first row of A is 4, 7, 6. That's the first row. What's the first column of B? Well, it's only 1 column, and that is 8, 5, 9. So what do I do with that? Look at number 3, elements in the product matrix, the sum of the products formed by multiplying each element in the particular row by the corresponding element. In other words, I now take the first entry of the first row multiplied by the first entry of the first column. So that will be 4 times 8. And then I add the second entry times the second entry of the column. 7 times 5. And lastly, of course, whatever's left, you can do that. 6 times 9. I worked it out. 4 8s, 32, 7 5s, 35, 6 9s, 54. What do I get as an answer? 121. And that is the value you put down here. 1, 2, 1. You need to definitely look through that again. Let's do the second one. So remember, pause and go through that again. Well, in the second one, that is the entry in the second row, first column, which means I must now take second row and multiply the second row of A and multiply it by the first column of B. So let's do that. What is the second row of A? The second row of A is 2, 3, 1. What is the first column of B? That's the same, 8, 5, 9. Let's work that out. How do I calculate this? First times first, 2 times 8 plus 3 times 5 plus 1 times 9. And when we work that, 16, 15, what is your answer? 40. And that is the second entry, 40. Now, that is how matrix multiplication proceeds. You need time to get this again. So pause the video, rewind, go back, look at it carefully, analyze it, establish your own procedure. If you don't like the way I've written it down, you write it down in a way that you understand, but you still get the same answer. Don't create anything out of the ordinary. Follow the theory. Okay, let's see if you've understood this. Let's look at example number 2. Now, a little faster now, but I'm going to do the check-in. You have to do the check-in first. But before you do check-in, what should you be writing down first? Order. Let's write down the order. The order of the first one, 3 rows, 2 columns. The order of the second, 2 rows, 3 columns. Is that the same? Yes. So what's the order of the answer? The order of the answer is going to be 3 by 3. So the order here will be a 3 by 3. Now what I tend to do, like I said previously, I tend to use dots to show me how many elements I must put in. So this means there's 3 rows. So going from the rows, there's 1, 2, 3 rows. And how many columns? 1, 2, 3 columns. And just complete the number of dots. And there you go. I need to find all those entries. Now let's see if you've understood that. Let's see if you've understood example 1. Let's apply it now to example 2. How do we find that first element there? In the answer, where does it stand? In which place does it stand in the matrix? It's in the first row and first column. And you always indicate rows first. So it's first row, first column. So what do? I multiply the first row of the first matrix, 1, 3. So it will be 1, 3. Multiply by the first column of the second matrix, which is what? 6, 5. and multiply in the proper order. 1 times 6, 3 times 5, 1 times 6 is 6, 3 times 5 is 15. Add those, 6 plus 15, there you go, 21. Did you get that? Now, I'm not going to go in any particular order. I'm going to jump around. Let me go. Let's find this one here. This one lies in which row? Third row. Oh, sorry. Third row, second column. So what do I multiply? What's the third row of the first matrix I'm multiplying? 6, 0. What's the second column of the second matrix? 6, 4. So this one here, let me just indicate it over here. To get that value, I multiply the second row, sorry, the third row of the first matrix, 6, 0. Multiply that by the second column in the second matrix, 6, 4. Put that in order. 6 sixes are 36. 0 times 4 is 0. What's the answer? 36. Can you complete all the others? Let's just do one more just to make sure you're getting that right. I'm going to find this one here, which is first row, third column. And I'm not going to write this down now. I want you to just look at it carefully. So there's the two matrices. There's the first one. I'm multiplying. There's the second one. The answer here is in the first row, third column. What's the first row? 1, 3. What's the third column? 1, 7. 1 times 1 is 1. 3 times 7 is 21. 21 plus 1, 22. Now, I want you to double check all the others. I'm simply going to write down all the answers and you check and ensure that you're getting the same. That one is 18. This is 52. This is 50. Second row, third column, 21. Third row, 36. And then third row, third column is 6. Ensure that you get every single element correct. If you get just one of those incorrect, at a later stage, it will put an entire problem completely in the wrong direction. So ensure the accuracy of each of these elements. Okay, let's look at example number 3. Now here, once again, I'm trying to get you used to the fact that the elements that you see does not necessarily have to be nice numbers. I'm using nice numbers in my examples because I want to get the concept understood and I want you to concentrate on things that you're familiar with. So multiplying straightforward numbers, that's easy. So hopefully the concept is now understood, but you still follow the same procedure. So example number 3, how many rows do we have here? In the first matrix, there's 3 rows. How many columns? That's a 3 by 1. In the second matrix, how many rows? 2. How many columns? 3. Can we do this? Oh, sorry, this. Okay, I'm right at the bottom of the page. Can this multiplication be done? No, because that's 1 and that is 2. It's not the same. Therefore, this is not possible. You cannot get an answer for this multiplication. This particular slide is important. So if you need to view it multiple times until you understand it, please do so. Let's go to the next slide. More examples. So yeah, I'm merely going to write down the solutions much quicker because I want to get a particular point across. Okay, so I want to find AB, So what will A times B be equal to? A is 2, 4, 6, 3, 9, 5. I'm multiplying B, 7, 1, minus 2, 9, 4, and 3. Can I do this? Let's check the order. That's a 2 by 3. What is this? A 3 by 2. Yes, I can do. And what's the answer? So that is the same. The order of the answer is a 2 by 2. So there's 1, 2 rows, 2 columns. How do I find the first one? First row times first column. 2 times 7 is 14. 4 times minus 2 is minus 8. 6 4s are 24. That gives me 30. You check all these answers. The first row, second column, 2 times 1 is 2. 4 9s are 36. Plus 18, that gives me 56. Second row, first column, 3 7s 21 minus 18 plus 20, that gives me 23. And this I've already worked out, 99. Okay, what about B times A now? Well, B times A, B is 7, 1, minus 2, 9, 4, 3. That's B. And what is A? 2, 4, 6, 3, 9, 5. The order, 3 by 2. The order of the second matrix, 2 by 3. Are these the same? Yes, they are. So I can do the multiplication. What's the order of the answer? The order of the answer is going to be a 3 by 3. Now notice immediately, this order is a 3 by 3. What was that order? 2 by 2. So here I'm going to have 3 rows, 3 columns. I'm simply going to write in all the answers: 17, 37, 47, 23. I think this is 73, 33, 17, 43, 39. But what is important about doing this? Well, I have A and B. In other words, when I multiply A times B and I turn it around and I multiply B times A, I do not get the same answer. In other words, matrix multiplication is not commutative. What do I mean by commutative? Well, in numbers, you know how to work out what's 5 times 6. 5 6s are 30. What's 6 times 5? You get the same answer when you deal with straightforward values. But in matrices, that doesn't happen. Although I'm not going to correct myself at a later stage, there are very special cases where it's true. And you'll get that to that possibly later in this lecture. So let's go to the next one. This is the last slide. Here I'm merely emphasizing a few things. Verify the following. Number 1. So this is number 1. This is a 3 by 3. This is also a 3 by 3. That is the same. The order is going to be a 3 by 3. And when you work that out, what do you notice? Ones I get diagonally, zeros all over. What matrix is this? The identity matrix. And here I want to emphasize many textbooks use I with the subscript to indicate the order What do I mean by the third order? Third order 3 by 3 identity matrix. So in the same way, what do you think I2 will be? The identity matrix for a 2 by 2 matrix. There will be 1 here, 1 there, 0 zeros. I3, I4, I5, and so on. Now, number 2, extremely important, because we're going to get to that application at a later stage. What is this matrix? This is a 3 by 3 matrix. But look at that X, Y, Z. There's 3 rows and there's 1 column. Now, the number of columns and the numbers of rows are the same, so I can do the multiplication, and the answer is a 3 by 1. So this is a 3 by 1. Now look very carefully. At first glance, you would say, no, but there's 3. They look like there's, no, there's not 3 columns. There's only 1 column. There's 3 rows. Yes, there's 3 rows. 1, 2, 3. But there's only 1 column. And the first entry is x minus 2y. That's not 2 columns. It's 1 entry with a binomial term, x minus 2y. But now where did we get that from? Well, you follow the same process. The order is important. This is a 3 by 1, and a 3 by 1 is going to have 1, 2, 3 rows with 1 column. So how do I get the first one? How do I get that? First row, remember, A11. What's the first row? The first row is 1 minus 2, 0. And what's the first column? The first column is x, y, z. So I'm just explaining how the x minus 2y was obtained. Then I multiply 1 times x, minus 2 times y, and 0 times z. And that gives me x minus 2y, which is what you see right there. Now you do the same and make sure that you get the second and the third entry correct. In number 3, I merely wanted to show you that we could also get the null or 0 matrix. What is the null? All entries 0. Again, you can check the order. This is a 2 by 3. This is a 3 by 2, which means that is correct. And the order of the answer is a 2 by 2. Number 4, show that if A is equal to 2, 4 minus 3, 1, and I2 is the second order identity matrix, then AI2 is equal to I2 times A. Now, let's just write down I2 first, but it's already on this page. I2 is equal to 1, 0, 0, 1. So what does AI2 imply? It means take A, which is 2 minus 3, 4, 1, multiply it by 1, 0, 0, 1, and get an answer, which of course is going to be a 2 by 2 answer. And also do the same, but now do it with I2 first. And the answer you get from here must be the same as that. Number 5, here I just wanted to show you that I could multiply 3 or more matrices. So here I've got A as 1, 1, 0, 2, 0, 1. Small b is minus 1, 2. C is 1, 1, 1. Remember, write down the order all the time. That's a 2 by 3. This is a 2 by 1. This is how many rows? 3. How many columns? 1. Do you know how to get A transpose? So first find a transpose, multiply it to B, get that answer, then take the C transpose, multiplied by that answer you got from the 1 and ensure that you get 0. That completes this particular lecture.